Hello there, my name is Dominic and today I have a huge power backup installation at my apartment. With me here, my baby, this is the Deye Sun 6 kilowatt solar hybrid inverter. And over here, this is a 5.12 kilowatt hour lithium-ion battery pack, also from Deye. Let's get started. But before you continue, I will please urge you, check the video description and watch the previous video I did about these two items, and that's the unboxing and full specifications. This is a communication cable meant to be installed between the inverter and the battery. After I mount both these devices onto the wall, I will do some settings on the screen so that I can get the inverter to communicate with the battery. I will start by mounting the battery to the wall. I've just marked the position of the first hole. Now to just make sure that it's level, which it is, and then I mark the rest of the holes. "41 kilograms, that's no joke." Here we go, always lift with your legs. Battery is secured to the wall in a nice dry place away from moisture and naked flames. I was supposed to use these expansion bolts, but they are too long and my wall here is not that thick. But what I've used is also plenty strong. I'll keep this safely in case I install this battery in a future more permanent location. To mount the inverter to the wall, I first of all need to secure these brackets to the inverter. I will then drill holes into the wall and use these expansion bolts to secure the inverter to the wall. The inverter is on the wall, level and perfect. What about the battery? I can live with that. Now it's time to connect the battery to the inverter through the DC breaker. I just inserted these cables so that I could test the fitting to here. Let me open this compartment. Just snag it up. Done. The DC cables are connected. And I'm now connecting the DC breaker in between the inverter and the battery. I will tighten everything once I have a good location for this DC breaker in between the battery and the inverter. I have already installed the AC breakers, DC breaker, as well as the protective earth cable. Let me just take you through my installation. Power from my grid comes through this AC breaker and it goes into the grid port of the inverter. The output, which is the load, also goes through this AC breaker and into my backup load. This is my protective earth cable. It's connected to the inverter and then goes down all the way connected to the battery. The provided earth cable was too short, so I had to make my own. Now let's talk about the function ports here. From the left, number 1, 2, 3, and 4 are for connecting a generator. This inverter has the ability to turn on the generator. For example, if there's no solar input, the grid is down, and the battery is low, then this inverter can actually turn on a generator. And you do the appropriate installation by utilizing ports 1, 2, 3, and 4. Number 5 and 6 are for connecting a battery temperature sensor, and that's if you are using a lead acid battery. But I don't need that since I will install an Ethernet cable from the inverter to the battery. That eliminates me using the battery temperature sensor. And finally, number 7 and 8 are for connecting a current transformer coil. This inverter didn't come with that current transformer coil, but it's normally used to track the consumption from your grid. If I turn this breaker on, this inverter should turn on. And indeed, it is on, but the battery is saying 0. So I first of all need to connect the communication cable from the inverter to the battery and have that communication done. But in order to do that, I first of all need to turn off the AC from the grid. On the inverter side, it's supposed to go into the BMS port, and on the battery side into the PCS port. This is the position I've chosen for my DC breaker, and as you can tell, the battery is a little bit offset from the inverter. This is the only space I could install these two things. I didn't want to install it below that beam because the exhaust comes from here. I didn't want that going below that. That's why I had to install it here. It was very hard because it's in between two pipes for the water heater and the lights. And because of these cables are too thick and I didn't want to coil them, that's why I chose to install the battery offset to this other side. And now it's time to turn on the battery. Switch on my DC breaker. Battery is on. I've already turned on the inverter. And there the inverter is in the on position. I just now need to configure the inverter so that it can communicate with the battery, and for that I'm going to need my user manual. This backup load breaker is wired directly to this consumer unit, and inside here I have another isolator as well as two circuit breakers, one for the socket outlets and one for the lights. So I have intercepted the power from here into the inverter and back here to power my backup loads. So with this setup, I do not even realize if the power is gone. The only circuits that I have not connected to my new backup load consumer unit are number 1, this cooker socket outlet, and number 2, the water heater in the shower. Everything else, including all the socket outlets as well as all the lights, have been wired through this new backup load consumer unit. I even added this twin socket outlet here that powers both my microwave as well as washing machine. This inverter works wonderfully with both. In fact, let me just turn on the microwave. That microwave is working directly from the inverter. And I'm going to simulate a power blackout right now by switching off this breaker. That has turned off, but my microwave is still working. The washing machine can also work. I have been using it too, and I'm very pleased with that. This shows that the microwave is pulling 1.46 kilowatts from the battery. You could hear the microwave beeping in the background, and there the consumption has gone down to 0.11 kilowatts. If you watched my last 2 live streams, you'll know that I wasn't happy with the crimping job that I did on the protective earth cable. That's why I bought a crimper and some lugs, and this is the end result. This is much better than that. You will also know that I bought this flexible conduit with the intention of hiding the protective earth as well as the Ethernet cable running from the inverter to the battery, and that's what I'm going to do right now. First, I have inserted my protective earth cable here with the intention of tying the Ethernet cable so that I can pull it through the other side. It's an advantage that this crimper also has a cutter. It's very hard to push the Ethernet cable through the conduit, but with my method, I can easily do that. And then I remove this tape and insert my protective earth through the other side. There we go. This already looks so much better. Now let's go through the inverter settings. Here is the home screen comprising of 3 inputs and 1 output. The inputs, solar panel, the battery, and the grid. The bottom right one is the backup load. If you tap on the battery, at the top you can see here BMS day. That means that this inverter and the battery are communicating. But before I delve into the battery too much, I just want to show you some of the settings that I had to do once I turned on this inverter for the very first time. In the basic setup, I had to set the time, but once I connected this inverter to the cloud via the Android application, the time just came on automatically. In the display, I just left this beep and auto dim on. Auto dim just dims this display after 5 minutes. The beeper is just an auditory alarm if anything wrong happens in the inverter. In the battery setup is where I did some of my settings. Activate battery. This feature will help recover a battery that is over discharged by slowly charging from the solar array or grid. I just had to leave that off. In the battery mode, I had to select lithium, but when this inverter came, it was in battery V. Now, let me read from the user manual what this means. Lithium control the charging and discharging process of battery under the condition of the BMS of battery is communicating with the inverter. Bat V control the charging and discharging process directly through battery voltage. Battery percentage. In the absence of communication between the inverter and the battery, use the battery state of charge SOC calculated by the inverter to control the charging and discharging process of the battery. And finally, no battery. Tick this item if no battery is connected to the system. You can press the enter button to enter the verify page. I selected lithium, and since I have selected lithium in battery set 3 here, you can see that the 00 at the top means that the inverter and the battery are communicating with each other. I just left everything else as it is here. Now let's get to battery set 2. On the left side is for the generator and on the right side is for the grid. This just says that this inverter is allowed to charge the battery via the grid. If we go back to battery set 1 and select parameters, you can see the battery capacity, maximum charging current, and maximum discharging current. I set this according to the user manual of the inverter, and let me read that to you. The total capacity of battery connected to this system, it can be used to calculate the SOC of battery bank under the use AGM percentage mode. Maximum battery charging and discharging current. For AGM and flooded, we recommend battery size times 20% is the charge or discharge amps. For lithium, we recommend battery size times 50% is the charge and discharge amps. For gel, follow manufacturer's instructions. Now, as you can see, my battery is 100 I had to input that manually. And the maximum charging and discharging current is 50% of the battery capacity, which is 50 amperes. And that's what I have set. And that's all to do with the battery settings. Now, another very important thing to note with these inverter settings is when you change something, you have to press enter to confirm it, like that. If you just leave it like that, the changes will not take effect. You have to press enter and then verify by tapping OK on the touch screen. We are now in the grid setup. I left this as it is. The mode is in general setting. The frequency is 50 Hz. We use 50 Hz in Kenya. The type is single phase. The inverter output voltage, I chose to leave it at 230 volts. And these are the other settings. I didn't touch anything here. The generator port use. Since I won't be connecting this inverter to a generator, I won't be messing with any of these other settings here. Then the work mode. I'm using 0 export to load. And the manual says the AC output power will only supply the backup load and smart load, if any. The inverter will neither supply power to home loads nor sell power to the grid. The built-in CT will detect the power flowing back to the grid port, and then the inverter will adjust its AC output power based on the detected value to prevent AC current from being output from the grid port of the inverter. Next, we have 0 export to CT. CT is the current transformer. We talked about the CT in my first unboxing and specifications video. 0 export to CT. The AC output power of the inverter will only be used to supply the backup loads connected, but also supply power to the home loads and smart loads, if any, connected. If PV power and battery power is insufficient, it will take grid power as supplement. The inverter will not sell power to grid. In this mode, an external CT meter is needed. The external CT meter will detect power flowing back to the grid, and then the inverter will adjust its output AC power based on the detected value. Now, that's too complicated for me. I'm just going to use 0 export to load because I'm not selling any power to my grid. We don't even have that system here in Kenya. And finally, advanced function. Again, I didn't touch anything here. I just left it as it is. and I don't have to worry even if I tap something. If I go back, that will not take effect because I have not pressed the enter button. So those are all the settings of the Deye Sun 6K inverter. Let's now check the battery information since the inverter and the battery are communicating well. The BMS says it's a Deye inverter. I know if I had a different brand of battery, it would communicate and say its name here. The battery is at 60% state. I know you can't see that because of my camera, but it's 60%. It's discharging. The battery voltage is 52.9 volts at 2.5 amperes, and the battery temperature is 26 degrees Celsius. Currently, the battery does not have any faults. So that's it when it comes to the settings of the Deye inverter and battery communication. Finally, let's talk about the Deye Cloud application. This inverter has built-in Wi-Fi. We already know that. Now, there was a reason I had to block the Wi-Fi serial number as well as the password and the serial number of this device in my first unboxing video. And that's because I had to use some of this information to set up this application here. And I'm pretty afraid of hackers, to be honest. Now, this is the application. We can see that the state of charge is 60%, and that's being discharged to my home load of 108 watts. This is exactly the same information that I can see on the inverter's display here. The application is known as Deye Cloud App. Inside the application, I had to create a plant, and this is what I have here. This is everything. If I had solar panels, they will be showing through here. And I don't need to be near to this inverter to see this information. As it stands, with the inverter connected to my Wi-Fi here at home, I can see this information wherever I may be. And that's very cool according to me. If I select data at the bottom, these are the graphs. The purple one there is the state of charge of the battery. It was coming down and then charging today. I love this application and the fact that this inverter has built-in Wi-Fi. You know, there are other inverters that you have to buy a separate Wi-Fi dongle to get this function out of the inverter. That's it. I hope you enjoyed this installation video. If you haven't, please watch my first video, which was the unboxing and specifications video. My third video is coming up, although it's going to be a few weeks since it drops, and that will be my full review of this whole system, the inverter as well as the battery, while adding solar panels to this system. I really want to know how much money I'll save on my power bills when I add solar panels. I did see a comment on my first video about the number of solar panels that I need, and they said that I need minimum of 4 panels, and I actually agree. That's it. Thank you for watching till the end. Please ask any questions you may have in the comments below, and I'll be sure to answer them in my third video. Hope you learned something new. Let's meet in my other videos, and goodbye.